Okay, so this video is just going to show you where our double angles are coming from. So if you want to see the proof behind it, or if you want to see where it's coming from, it might help. Go ahead and watch. If you just want to see the formulas, memorize them, go ahead and go to the next one. But it's pretty cool to see, and it helps people remember them. So what we really have is we have the sum of two angles. But in this problem, we're actually adding two of the same. So that makes it 2 theta. We're just going to write it as theta plus theta. So if we apply our sum formula for sine, we're going to do sine of my first angle times cosine of my second angle, but in this problem they're the same, plus sine of my second angle times cosine of my first angle. If we go through and simplify this, I have 1 sine cosine plus 1 sine cosine gives me 2 sine of my angle cosine of my angle, and that right there is the formula for a double angle. So sine of 2 theta is equal to 2 times sine of the angle cosine of the angle. We'll do the same process with a cosine. This time we're going to use the sum of my cosine formula. So we're going to take cosine of my first times cosine of my second, flip your sign, and then sine of my first, sine of my second. Now if we go through and simplify this, cosine times cosine gives me cosine squared, sine times sine gives me sine squared. So I have cosine squared minus sine squared equal to cosine of 2 theta. There's a double angle for cosine. If we want to come up with a couple others, so now almost always you can use any of the three. We're going to have 3 total double angle formulas for cosine. So there are instances where one would be more useful than the other. So we'll call this one number 1. If we want to find number 2, I'm looking at cosine squared and I'm thinking Pythagorean. So I know that cosine squared is equal to 1 minus sine squared of theta. From the Pythagorean properties, we already have a sine squared. So then if I look in here, I'm saying, okay, I have 1 minus 2 sine squared of theta. There's the second double angle for cosine. Remember, sine only has 1. Cosine is going to have 3. So there's my second. And then my third, I'm going to go back to the original and do the same process with sine squared. So I've got cosine squared minus, and then sine squared is equal to 1 minus cosine squared of theta. If I take care of this property, or I'm sorry, if I distribute, we get cosine squared minus 1 plus cosine squared. In the end, we get 2 cosine squared of theta minus 1. And that would be your third double angle for cosine of 2 theta. And these are on the next slide, but this just shows you where they come from.